Good day students, how are you all? Hopefully you are well. Today we are going to discuss about chapter 13 and this is your third lecture, and this third lecture consists of 2 CQs and some MCQ, and 2 CQ will be depending on your board Dhaka board 17 and Dinajpur board 17. This is the question from Dhaka board 17, and our question says the height of a right circular cone, it's a cone, is 8 centimeter, and the radius of its base, so the cone's radius is 6 centimeter. It is melted and formed into several number of solid sphere. So cone now melted with solid sphere with the diameter 4 centimeter. So here is given the diameter, which is 4 centimeter. And our first question says find the area of curved surface of each sphere. So we need to find the area of curved space. So here is given the solid sphere or the curved space. So we have to find this. Now solution number 1. Solution number 1 is area. We have to find the area. Area of curved space. Area of curved space will be 4 pi r square. We know this. Where r is represents the radius. R represents the radius. Given the radius r, so not this r, it will be small r, and this r is 4. This is our diameter. If we divide it by 2 in this diameter, so 4 by 2, then we will get our radius. So 2 meter. 2 meter is our radius, and we have to just put the values of r into here. Then we will get the area of curved space. So it will be 4 pi into 2 square. So that will be 16 pi, and that is our required answer. But if anyone want to put the value of pi, and we know the value of pi is 3.1416, that will be 16 pi will be 50.27 approximate values. This can be the answer. Also the answer. So our answer will be this or this. Any two will be okay. Now we are going to our next question, that is find the whole surface area of the right circular cone. What we have to find? Find the whole surface of area of the right circular cone. So whole surface area of the right circular cone. What is the formula to find out the area of right circular cone? What is the formula to find out the area of cone? Area of cone is pi r into r plus n. Pi r into r plus n. Okay. Let's go for our second math. Our second math here is given. We have to find the surface area of the right circular cone. We know the area of right circular cone. The area of right circular cone will be pi r into r plus l. Pi r into r plus l. So here pi into r, and the value of r will be the radius of cone. The radius of cone is given. Here is the radius, and this is the radius of cone. So the radius of cone is 6 meter. So just put the value of 6, then r. The value of r is what? The value of r is 6, and now the question is L. What actually the L? L is our silent height. L is our silent height. So just write given the radius of cone is 6. Radius r is given, that is 6 centimeter. Then here is given the height also. Height is 8 centimeter. So if we know the height and also the radius, then we can very easily find the salient height, that is L. We know the salient height L will be root over h square plus r square. So the value of h is 8 square plus 6 square. So it will be 64 plus 36. So 10 is the value of L. Just putting the value of L in here, then we get 6 pi into 16. If we multiply 16 into 6, then it will be 16 into 6 will 96 pi. You may give it as answer, keep it as an answer, or you may putting the value of pi in here. Okay, the value of pi will be 3.1416. Okay, thank you. Now, so our third and last question says, find how many solid pairs can be found. How many solid pairs can be found? What actually happened from here? Here is given the cone, and this cone was melted and formed into several solid pairs. So cone converts into solid sphere. Suppose the cone is the huge thing, and we will get some solid sphere from the cone. Okay, so we need to find the volume of cone, and also we need to find the volume of solid sphere. So here we know the volume of cone. What is the formula for the volume of cone? Volume of cone is 1/3 pi r square is 1/3 pi r square is. Here 1/3 pi r means actually the radius of cone, that is actually 6 square into h, that is the height, that is 8. So if we multiply with this into this, then what we get from here? If we use calculator, then it will be 8 into 36 divided by 3. It will be 96 pi. It will be 96 pi. And now again the volume of solid sphere. Why? Because cone has converted into solid sphere. So the volume of solid sphere is what? 4/3 pi r cube. 4/3 pi r cube. This is the formula. So just putting the value of r in here, 4/3 pi, and the value of r here was given the diameter, and we know the diameter can be converted into radius by dividing by 2, so it will be 2 cube. So it will be 8 into 4 divided by 3, so 32 pi by 3. This is the volume of solid sphere, and this is the volume of cone. Now the question is, how many solid sphere will we will get from the melted cone? So the question was, how many solid sphere can be formed? So the solid sphere can be formed. Solid sphere can be formed. Solid sphere can be formed. Cone 96 pi divided by 32/3 into pi. So pi and pi can. So 96 into 3 divided by 32. 96 into 3 divided by 32. It is 9. It is 9. So our 9 pieces of solid sphere can be formed from the cone. That is our main answer of this question. So 9 pieces of solid square will or can be found. This is the solution of this question. End of question. Okay, so our next question is question number 2. This is given as just figure, and this figure has shows or given some information. The information is given here, the radius of this circle and the height. These two information are given, and we have to find this from the cylinder. What actually we have to find the area of the cylinder we have to find. This is the question number 1. Then find the area of the curved surface. Just we have to find the area of the curved surface, then whole surface of the cylinder, then whole surface of the cylinder we have to find. And finally we have to find another question, that is if we just spherical ball exactly fits into the cylinder. If we are trying to give a ball and this is exactly fit in this cylinder, then how then find the volume of the occupied portion of the cylinder. That means if the ball exactly fit here, then how much empty places we will find. This the part we have to find. Okay, now our first question is talking about find the area of the base of the cylinder. How we can solve these types of math? So we know the area of cylinder. Solution number 1, we know the area of the cylinder will be pi r square. Why? Because this is just the actually area of cylinder, not actually the area of the base of the cylinder. The area of base of cylinder, that is the base, and this base actually represents the circle. So we need just the area of the circle, and the area of the circle will be pi r square. And here the radius of the radius is given. You may write here that given the radius r equals to 5 centimeter, which is actually here given. Now putting the value of here, pi into 5 square, so 25 pi. This is the answer. Since here all of this is centimeter, so it will be centimeter square. So this is the question number 1. So now our question number 2, here is given the find the area of the curved surface and whole surface of the cylinder. So we have to find the curved surface. What is the area of the curved surface? The area, we know the area of curved surface. The area of curved surface, only we have to find the area of curved surface. Area of curved surface is 2 pi RS. 2 pi RS. So area of curved surface of a cylinder will be 2 pi RS. Thus putting the value in here. So 2 pi, here R is given, that is 5, and H is 10. So if we are trying to multiply, so 10 into 10, it is 100 pi, and that is the answer. This centimeter square. And now we have to find the whole surface of the cylinder. This is also we have to find the area. Again the whole area of the surface of the cylinder. The whole area of surface of cylinder will be 2 pi r into r plus s. 2 pi r into r plus s. This is the formula to find the whole surface of the cylinder. So just putting the value of here, 2 pi into r. R is 5, and r plus s, that is 5 plus 10, it will be 15. So 15 into 10, it will be 150 pi. This is also the answer. These two are all. Thus here is 5 plus 10, 15. 15 into 2, 30. 30 into 5, that is 135, 150 pi. So this is how we can solve this question. Okay. So now our final question, question number C. a spherical ball exactly fits into a cylinder, find the volume of the occupied portion of the cylinder. What actually talking about this? Actually, if the cylinder looks like this, suppose this is our cylinder, and if a ball, suppose this is our ball, and this ball is exactly fitted, maybe not is the actually perfect flow, it should be the exactly fitted. That means it will be like this. Like this. So this ball actually exactly fitted to the cylinder. So now question is, what is the unoccupied portion? That means the ball actually covers this part. Ball covers this part, and we know this is just the so the unoccupied portion, that means this part, this part, this part, and this part. So these four part we have to find. So these four are the unoccupied portion. So how we can solve these types of math? If we can formulate, or we can find the volume of total cylinder, and if we find the total volume of the ball, then just subtract this to volume, then we get the unoccupied portion of this surface. So here the volume of cylinder is pi r square s. We know the formula. The volume of cylinder is pi r square s. Just putting the value of r and s. Here the value of r is 5 and s is 10. Just put these 2 points, then you will get the volume of the cylinder. This is the first fact. Second fact is radius of the ball is given, that is 5. Radius of the ball is given, that is 5. So if the radius of the ball is 5, then what will be the volume of the ball? The volume of the ball will be 4 by 3 pi r cube. So just put the value of r, then we'll get the volume of the ball. Now what we are actually get or observed or obtained, we get the volume of the cylinder, first thing. Second thing is we get the volume of the ball. If we subtract these two parts, then we get finally the occupied portion. So the volume of unoccupied portion will be this total volume of the cylinder and minus the volume of the ball. So we just subtract these two, then we get the volume of the unoccupied portion. This is how we can solve these types of math. And now our second part is goes on to the MCQ. MCQ is also based on the basic. So basic and MCQ are very much close to each other. Thank you. Dear students, how are you all? Hopefully you are well. Today we are going to discuss about chapter 13 on your higher mathematics, and this is on your solid geometry part. Actually this is the part where we are discussing about the properties of solid and the surfaces, lines and the points. Actually this is also called, or the solid geometry also known as the geometry of space or 3 dimension. Actually today we are going to discuss about the basic thinking or basic concept of the solid geometry, and it is also very much important for your MCQ too. So it's very possible, if it is possible to take it as basic as well as MCQ, it will be very much helpful for you. Okay, today here the chapter 3 are talking about the solid geometry, what I have been just said, and this solid geometry are also known as geometry of space or 3 dimension or geometry of 3 dimension. Every two name are very much familiar or very much synonym for the solid geometry. Okay, now we are discussing about the dimensions. What actually the dimensions, and why we are talking about the dimensions in these sections? Because solid geometry is a geometry where you have to think about the dimensions. Here we know that there is different types of dimensions, 1D, 2D or 3D. It is very much useful name for, or it is very familiar name for us. So here dimensions, the definition of dimensions says that if each of the length, breadth and height, what I have been telling it, that each of the length, breadth and height of a body is called the dimension. So if there is a length, then it is only length, no breadth and height, then it will be 1D or one dimension. If there is length and breadth both but not height, on that time you can say it is the two-dimensional. And if there is length, height and breadth, all three are present there, then we can say on that surface or on that body is known as the three-dimensional body. Okay, now there is some examples to understand the dimensions. That's why I am first take the name as point. What actually the point is? I have written here that point has no dimensions. Why? Because if we see the figure of point, it looks like this. This is a point. In this point there is no length, no height or no breadth. So it is just a position, and actually this is not positional positions also. This is called actually the positions, where it has only the position but no length, breadth or height. That's why it is called as no dimensions. Okay, now line. What is the figure of the line? The figure of the line is like this. In this line actually it has only the length, but there is no breadth or height. That's why we can say this is the 1D substance. Here the surface generally looks like this. On that surface we are seeing that here the length and the breadth, both length and breadth are present. That's why it can be said as it is the two-dimensional body, and the example of two-dimensional body is called the surface. Here I wanted to talk about different type of surface too. Actually surface can be the plane surface, and there is another surface that is called the curved surface. What actually the plane surface or curved surface is actually, if we relate in our practical life, this is the board. We may think that this board are, if we are thinking this the plane of this surface, then this is the breadth and this is the height, this is the length and this is the breadth. If we are thinking just these two parts, not the total board, actually just the plane of the board or the surface of the board, on the time this board can be talking as well, or can be assumptions. If we are thinking that this is the board and this surface are actually the plane surface, this surface are actually the plane surface. Or if we are thinking that the pond, the still water pond, generally we are seeing that on that water can be talking about the plane surface. But if we are thinking the circular thinking, it can be looks like ball, it can be a ball. On that ball we know the ball of the surface of the ball, that is the radius. On that time we can say that is the curve, or the surface of the ball is a curved surface. Okay, now we are talking about the cube cube. In that cube, what is actually the figure of the cube? The figure of the cube can be looks like this. The figure of the cube generally looks like this, where all length, breadth and height, every three parts are available in there. That's why it is called as 3D. These are known as the three-dimensional part, or 3D or three-dimensional surface. If we are thinking the whole board, on that board what we are seeing here, so look at the board here. This is the part what we are talking about. This is the length, this is the breadth, but what about this? Here is some height of the board, or the thickness of the board. So here three particles are there. That's why our total board can be think about that this is the three-dimensional part. Or as a if we are talking about a book, you are thinking the book of the, or suppose this is the calculator. In this calculator you are thinking that this is the length, this is the breadth and this is the thickness of this, can be talking about the height. So this is the concept of three-dimensional. Okay. So now we are talking about some formulas. In this solid geometry part, we are trying to see some types of formula or some types of shapes we will get, and we need to know how the shapes looks like, or what is the formula to find out the shape. Suppose in this solid geometry part, we have to deal with rectangular parallelepiped or cube or pyramid or prism. There will be some circular part, cones or cylinder. So different types of shape we will get. On the time, we need to know actually how we can find the shape, or how we can find those shape of area. That's why we need to know some formulas. Here we need to know the formula of the rectangular parallelepiped. What actually looks like a rectangular parallelepiped? It can be looks like this. Suppose this is a rectangular parallelepiped. In this rectangular parallelepiped, there we will find three parts or three properties. One is its length, and there is a breadth, and there is also a height. If we are considering our length as L and our breadth as B and our height as C, then we can talk about the formula of the area of the surface. I mean the area of the whole part will be 2 into AB, that is length into breadth, plus BC, that is breadth into height, plus CA, that is the height into length. So this is the formula to find the area of the surface. And how can we find the volume of that surface? The volume will be just the multiplication of area, length, breadth and height, that is A into B into C. So this is the way we can find the volume of that part. Now we need to know how we can find a diagonal of this part. Generally these diagonals can be understood by you very easily. That's why I wanted to see you or show you a rectangle. If it is a rectangle and there is two part, that is length and breadth, then what will be its diagonal? Its diagonal must be this part. And when we are talking about this part, we always try to find this length by using Pythagoras formula. And if we are using Pythagoras formula, then we can get root over a square plus b square, isn't it? If this is length, this is breadth. So since here is three components, that is length, breadth and height, that's why the diagonal will be looks like this, and here three components will be coming. On the time we will get actually root over a square plus b square plus c square. This is the way to find the rectangular parallelepiped diagonal. And now we are talking about the cube. How we can find the area of the cube? The area of the cube can be found as actually what actually the similar part of the cube and rectangle. We need to know that in this cube part, actually here we are seeing the three components, that one is length, breadth and height. But in the cube part, actually all the length, breadth and the height would be same. So the length, height and breadth would be same. On the time we can say A is equals to B is equals to C. All are actually equal. If all are equal, then the area of the surface will be 6a square, area of the volume will be a cube, and area of the diagonal will be root 3 into a. Maybe one question arised in your mind, why we are talking about this is 6a square, or how it comes, isn't it? If your question looks like, then just putting the value of a at the place of b and c. Suppose in this part 2 into a plus a into a plus a into a. So from here we can write 2 into a square plus a square plus a square. So it is 2 into 3a square, that is 6a square. Okay, so 6a square will be our area of surface. And similarly, if we are putting the value of b and c here, a and a, then a cube, and here also a square plus a square plus a square, that is root over 3 into a square, so root 3 into a, because square and root will be gone. So this is how we can find the formulas of the cube. But it is also very important to know the formula of the area, volume and diagonal of cube too. Okay, now we are discussing about two parts. One is prism and other one is pyramid. In these two topics, generally you are very much worried about this, but I wanted to make you clear what actually the pyramid and what actually the prism, and how to solve these types of math also. Okay, first of all, what actually the prism is. Here is a definition what can be found by our book or the textbook. That is, a prism is a polyhedron. This is the number 1. 2 is bounded by two parallel polygonal face, and other faces are always being the parallelogram. What actually talking about these three parts? Actually, if we are talking about the definition, if we are trying to give the definition of prism, it looks like this, that here we will see two base. On that two base will be the identical, or the two sides of the prism will be the identical. Generally, what we are talking about, or what looks which types of prism generally we found, it maybe looks like this. Maybe looks like this. Okay, maybe looks like this. Suppose here is a triangle and here is also a triangle. This actually this is a triangle, and these types of triangle can be found here. So this is the base part, we can say this is the base part. Or if we are trying to take this position is vertically, this is the horizontal part. If we are trying to take it vertically, then we can see that this part and this part, or that this triangular face and this triangular face are equal. First of all, there is no rules that all of the part or all of the base must be same. Here the base is this, actually base is this is also the base. This base can be the polygon, so there is not hard and right rules that it must be a triangle. It can be a polygon, that is triangle, quadrilateral, pentagon, hexagon, anything else. Okay, we are trying to draw a pentagon, actually pentagon. We are trying to draw a pentagon, actually. It can be like pentagon. So 1 2 3 4 5. Okay, this is a pentagon, and here we will see a same pentagon in here. If we are trying to add this, okay, if we are trying to add this, then we may think that the replica of this part is here. The replica of this part is here. So this is looks like this part. Here is a surface and here is the other surface. This can be talking about base, and this can be talking about the top. Or we are thinking that this is the base. This is the basement, or this is the base part, and the other part and the actually the inner part of this generally called as the lateral part. Okay. So the volume of this prism, is talking about the area of base into height. Just we need to find the area of base. Why we are talking about area of base? Because we don't know which types of polygon we will take. If we are taking the base as triangle, then we have to find the area of the triangle. If we are trying to find the pentagon like this, or hexagon or octagon, anything else, so we will find those polygons area. That's why we are talking about the volume will be area of base into height, and the lateral side area it will be, actually this is called lateral surface area. This lateral surface area will be the perimeter of base into height. The perimeter of base, we have to find the perimeter of base into height. and the total surface area will be the lateral surface area plus 2 into area of base. Here again one question in your mind, that why you are going for 2, because here is 2 base, that's why you have to multiply here by 2. Okay, now what actually the basic difference I wanted to show, that is the pyramid. In this pyramid there will be one surface, that surface will be looks like, actually we are talking about the same pentagon also. This is the pentagon, and here there will be a point, not the same pentagon will here. If we are talking about prism, then we also need a actually pentagon looks like this, but at the case of pyramid we need only a point, and here will be a base, and this base is a polygon, and here we are taking a pentagon as polygon. In this pentagon there is 5 vertex, and we have to just add all the vertex with this point. If we are adding, then we get a pyramid. So how? Suppose this is one part, second part, third part, fourth part, and fifth part. So here all the vertices have been added with the point. So we can say this figure is a pyramid, and in this pyramid we can find the volume of the pyramid and the lateral surface area and also the total surface area. How? Here the volume will be 1/3 into area of the base into salient height. One thing arises in your mind, what is the salient height? As the salient height is this is one types of height. Here actually just think about that. Here is a surface, here and there is a pentagon, and there is a point. This point actually added all the vertex. So all the vertex, since it is added, so all of the height will be looks like this, not the directly the perpendicular. It is just a it's just obtuse actually the surface. That's why we will take a point in the middle, then just add this, then we will get a height. And this height is generally known as the salient height. Okay, when you are trying to solve this types of math, then you can understand very easily that what actually the salient height is. Now the lateral surface area will be half into perimeter of the base into salient height. Why half? Here was not the half, but here is half, because here is only one base, and here the total surface area will be lateral surface area plus area of the base. There is the absence. We are thinking that 2 is not here. Why there is no 2? Because here is only one base, that's why. Okay, so this is the total discussion of prism and pyramid. Okay, so this is the last part for our formula. So mind it, my dear students, we need to memorize this formula, all of the formulas, because all these formulas are very important for our MCQ part 2. Okay, so now we are first here the topic is the right circular cone. Actually what the cone looks like, there is a taboo or the taboo. Actually these types of taboo are known as the cone. These are known as the cone, and these are called as the right circular cone, because if there is a right angle triangle, if this right angle triangle can be rotated like this way, then these types of cone are created. Okay, so the area of the surface, actually the previous part we have seen that always we are finding the area, but these types of part we need to find the area of first the circular part, then area of the total part. So here the area of curved surface or area of circular part is pi RL, and area of whole surface is pi r into r plus h. There is two part, one is this and other is this part. So area of these two part, if we are adding, then it is come pi r into r plus n, and volume is 1/3 into pi r square h. My dear student, no need to be worried, because when we are trying to solve these types of math, then again I will explain all of this. Okay, so first thing is we need to know the formula for our basic part or the MCQ part. I have this pair also. what actually, how a sphere can be a circle. Actually sphere can be a circle. So in this circle, we know the area of the circle is the area of the surface is actually, this is the surface. We need to find out the surface, not the circular area. Okay, area of the surface is 4 pi r square and the volume is 4 by 3 pi r cube. And finally the right circular cylinder. We know the cylinder is, generally cylinders looks like this. Cylinders looks like this. Here two circular part is there. Actually this is not correct, the drawing is not appropriate. Actually the same types of cylinder will be here and here. That's why in this cylinder part we need to find the area of the curved surface. Area of the curved surface will be 2 pi r h. So the area of the curved surface is 2 pi r h, and the area of total cylinder will be the full cylinder will be 2 pi r into r plus h, 2 pi r into r plus h, and the volume will be pi r square h. So here we need to find actually what actually r and h. Don't worry, actually r is the radius of the the circular part, and h, that is the height, actually height of the cylinder. Okay, here also the r actually the radius, you know, that's why I just skipped that part. And here actually you know also r and h. R is the radius, h is the height, and l is the you know the height, it is the salient height, and this salient height can be known as the L. Okay, so this is all for our today's discussion, or actually the MCQ part.